Hey everyone, it's week 2, and we are going to blink again, but this time we are going to use inputs and outputs and physically connect them to the microbit to make a circuit. We are going to need a few things to do this. We're going to need our microbit, the battery pack, and the USB cable that connects it to the computer or Chromebook. We are going to need those LED lights that are in that plastic bag, and we are going to need the alligator clip cables. We're going to need ones that have the alligator clip on both ends. And here we are in the makecode.microbit site, and I have a new file, basically my blank screen right here. And again, I want to program blinking lights. Now, I got my emulator right here showing my microbit. Last time we got out the basic blocks and we made things happen right on the microbit. This time, however, we need some different blocks because we are going to hook up physical components. We are going to hook up those separate lights, the LED lights, not the ones that are in a grid on the microbit board, but the ones that come in the little plastic bag. So we are going to need code to hook up physical cables and lights to the microbit. Now, I'm also, because I'm going to be using batteries, I'm going to want to be able to turn it on and turn it off in case I want to save power. One other thing to keep in mind are inputs and outputs. If you remember the vocab sheet for this week, an input is information that is coming into your computer, in our case, into the microbit, and an output is information going out of the computer or the microbit. Now, on a computer at home, an output might be something like your monitor, which gets the visual information from the computer displayed on the monitor, or a printer, which gets the information out, or speakers, which get sound out of the computer. Those are all output. An input might be a keyboard or a mouse or some other kind of a microphone maybe, or any other kind of device that feeds information into the computer. In the case of our microbit, the input for this lesson are going to be the A and B buttons. This is going to let us turn the lights on and off. And our outputs are going to be LED lights, at least to begin with. So this is what we want to keep in mind. I'm going to grab my input and I'm going to take the on button A pressed block. Now, with this block, I can put my code in here, and I can, when the button A is pressed, the code that is in here is what's going to happen. Now I'm going to go ahead and grab another one of these. And if you'll notice, this little A here has an arrow. I can change this to a B button. So now I've got commands for the A button, commands for the B button. So what I want to do is I want to have lights that are connected to the microbit turn on and then turn off. And at its most basic level, it's just simply going to be a light that turns on when I press button A and a light that turns off when I press button B. Now, where am I going to connect my lights? And the answer was also in this week's vocab, the pins. These round holes at the bottom edge of the microbit are your pins. And you can see they are numbered 0, 1, 2, 3V, and GND. GND stands for ground, and this is going to be important in our circuit. Now, I'm just going to use the farthest to the left. I just call this the first pin, pin 0. And what I'm going to do is grab something that will let me affect those. So pins can be input, pins can be output, and so I don't really see anything in there. Well, here's something that says pin, but this doesn't fit in my code block right there. And you can see that red dot says, hey, that's not going to help you. So I'm going to get rid of that. And I am going to go to my menu here of drawers, and I'm going to click Advanced. I'm going to go down a little bit, and here is a pins drawer. And so I'm going to click on that. And here's a couple other terms for you: read and write. So on the microbit, read is input, write is output. Read is information coming in, write is information going out. So I want the light to turn on when I click the A button. So A is the input and my pin is the output. In this case, it is pin 0. So, and I did a digital write pin. We use digital when things are going to be on or off. So again, digital is when it's on or off. I have other pin options in here. I can get analog, and analog is when the value is in a range. So for instance, if I'm going to be able to turn the sound up or the sound down, that is a range of sound, and that's when I would use analog. If I want a fixed number, I'm going to use digital. And in this case, our fixed number is either going to be 0 or 1. 0 is off, but I want button A to turn my light on. So I'm going to make the code on. Now, if button A will turn my light on, button B will turn my light off. So I'm going to grab another one, or I can just right-click that code block. I can duplicate it. I can put it into button B, and I can, change the value to 0. Again, 1 is on, 0 is off. Now, let's look at my emulator. Let's see if it works. I click A. Now, you don't see a light coming on anywhere, but you do see that pin 0 is highlighted. That means pin 0 is active. It is going to be getting some kind of electronic current or signal. Let's see if B works. Like B, and the command is turn digital write pin 0 to 0, turn it off, and you can see it's not highlighted anymore. It is off. So according to the emulator, the code is working. Let's take a look and see if this code works in real life. I will start by downloading it. And again, you can see it spin, 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 spin. The message pops up. We ignore this, and right down here, my file has downloaded to the lower left-hand corner. And if you lose track of it here, you can always find it in the downloads folder of your browser, or on your computer. So there we are. I am going to go to show in folder to see it. Let's load this onto the microbit, and let's make the circuit connect. Before we begin, remember, a circuit is a closed path for the electricity to flow from the power source through the light and then back again. Here is our microbit connected to the computer in this case. It could be connected to your Chromebook with a USB cable. And I'm going to download our file. And this file is not to blink yet. It's just to see if this works, turning on and turning off a light. So lower left-hand corner of my browser is where it downloads. And I'm going to show in folder. We've been through this before. I'm doing it quick. And I'm going to just click on this file and drag it to my microbit over here on the left. And you can see the microbit is rapidly blinking, which means it's receiving the file. Now, our file is going to blink the light if we press button A. But it's not going to work on the microbit because we are activating the pin. We're not blinking the lights on the LED like we did last time. Now, we have to complete a circuit for this to work. So not only does our code have to work, but we have to make sure that we are making a complete electrical circuit. So what I'm going to do is bring out an LED light, and I am going to bring out a red and a black alligator clip cable. Now, I have chosen these colors because often in electricity, red is going to be your power or your positive. Black is going to be your negative or your ground. And you'll see, for instance, on car batteries all the time, the red and the black cable. If you're looking at your household electricity, like light switches, don't necessarily trust red and black. It's not always the case, and you should always be really, really careful when you deal with electricity. But for our purposes right now, we're going to go with red for positive, black for negative. All right, so here's my red. And then the other thing is, on our LED light, one side, one stem, I should say, on the light is slightly longer than the other. And so I'm going to identify the slightly longer side, and I'm going to put the red cable. That is the positive side. The slightly longer side is the positive side. If you get them mixed up, then your lights will not work. Of course, it's an easy fix. You just switch your cables. And then my slightly shorter side is my negative side. I clip my cable on, and connect it to the ground. So we activated pin 0 in our code. So that's our hot pin, or the pin that the power is going to go through. So pin 0 is our positive. And then almost always the ground is your negative. That is the far right-hand pin, the one that's labeled GND. So we've got everything hooked up. I hope our circuit's solid. Let's see. And our light is on. We have success. Well, wait a minute. Does it turn off? It does. B button turns it off. Our code is good. Our hardware is connected correctly. We have success. Now, let's look at how we make this blink. Okay, now that we've gotten our simple circuit to work and we have made sure that our code works with our hardware, now we are going to do the blink. And we also want to make sure that our inputs turn it on and turn it off. So remember, blinking just means going on and off at a repeated pattern or a repeated length of time. And if you remember from last week, our on is right here, digital right pin set to 1. And last time, when we blinked, we added a pause, and then we set the number of milliseconds. They have 200 here. I'm just going to go with that. And so blinking is on and then off. If we wanted pin 0 to be off, what would we do? We have our hint right over here. Change your setting to make it go off. You will probably need another one of these. And then you also are going to need the blinking to repeat. If you do that, you are going to need a loop. And so if we grab, and then we may want it to do a certain number of times. If we know how many times we want that to happen, then we can do that. Or if we just want it to happen until we turn it off, then we grab the while true, and all of your information now would have to be inside the while true, which would go inside your button A. And again, I'm going to let you figure that out. And if you can't figure it out and make it work, I will be available at 2 o'clock on Thursday or by email. And my email's in the Google Classroom. One other thing, button B pressed is for pin 0, but button A is saying while true. Well, once you have pressed button A, that's going to continue to be button true. That's going to continue to be true. Even if you press button B, well, you still did press button A. That is true. And so you're going to need a way to reset what is happening and reset it to digital right pin 0. And your hint is in the control drawer, you have a reset block that you can get. Now keep this in mind also. The code, if it's not inside a loop, is going to follow the instructions in order. When you add the reset, make sure you're resetting it in order. You want to reset to a condition that you state, in this case, that pin 0 is off. Reset pin 0 to 0 or off. Those are your hints. Now download your file to the microbit and see if your light blinks. Email me or see me on Thursday if you can't get it to work. And in the next video, there are some ways that you can make your blinking, make your lights more complex.